Good evening to people in India and good morning for my friends in USA. I have great pleasure to introduce Mr. Shamil Bicha, my good friend. He's a mechanical engineer from Madras University and did his master's in industrial and systems engineering from the California State University, San Jose. He has worked in companies like Applied Materials in Santa Clara, and he's currently the vice president in Avalon Technologies, Chennai, from 2002. He is a member of the Executive Council of the Indo-American Chamber of Commerce. He's a member of the various trade chambers, Surface Mount Technology Association, Coffee Growers Association, Hindustan Eagles Football Club, World Wildlife Fund. You see such a multifaceted person out here and a great friend. Over to you, Shamil, for the session. Thank you.
Thank you, Shekhar, for the kind words. Welcome to everyone for an exciting session on electronics and semiconductors. No matter what you do or where you are, electronics is touching our lives very deeply and ever increasingly so. Today, whether it's the gadgets we use, the cars we drive, or the medical equipment which is used to diagnose our health issues and sort it out, or for the food we eat too is extensively using electronics, and for that matter even the wars we fight today have an extensive use of electronics. Today, we're very fortunate and honored to have a very distinguished panel, all superstars in their own right in our world of electronics and semiconductors. We hope to engage them and to get a picture of where India is today and the road ahead for us to tap into the limitless possibilities of this industry. I'll introduce one by one the panelists, following which I will ask specific questions to each of the panelists, and then later have some general questions which the panelists can respond to. So first of all, Mr. Krishnamurthy, he's industry veteran, currently CEO and president of Indian Electronics and Semiconductors Association, better known as ISA. He has extensive background in leading innovation and R&D teams for global companies like Rambus, National Semi, and he also had started off his career in Bharat Electronics. He's an extremely strong force in making India a strong electronic system design and manufacturing destination. I hope to touch upon that specific area when we get to talk to him. The next panelist we have is also a combination of being an academic as well as being an industry leader. Is Dr. Ravi Bhatkal. He is a PhD in material sciences, and his company, he's the MD of McDermott Alpha Electronic Solutions. He serves as a member of INEMI, a global electronics consortium, industry consortium. He's on the advisory board of various research and academic institutions. Ravi is widely published and also has several patents to his credit. Welcome, Ravi. We also have with us today Mr. Vinod Sharma. He is, in many senses, a maverick. India has always had a challenge of component manufacturing. He has been making capacitors very passionately for almost from the 80s itself. He's instrumental in making Deki Electronics, his company, a world-class capacitor manufacturer. He has been the president of ELSINA, ESC, the Electronics and Software Council. He's currently chairman of CII's National Electronics Committee. Vinod is also a keen trainer and consultant and devotes plenty of his time towards enhancing competitive management skills in managers and entrepreneurs around the world. So it's a really very established and panel we have today. I will now start off with a question to Mr. Krishnamurthy. Mr. Krishnamurthy, you've had many leadership positions in R&D outfits of companies like Rambus and National Semi. You're pushing India very strongly to becoming an innovation-driven economy. You've been very involved in the ESDM area, the electronic system design and manufacturing area. Could you help us understand the current landscape in India and what perhaps needs to be done to make India a serious force to reckon with in the ESDM area?
Okay, first of all, very good evening to all the participants from India, and a good morning to all of you for joining from the United States. And thank you, IACC and Shamil, for getting me onto this panel. In order to outline the landscape of ESDM in India, which essentially encompasses the electronic systems, semiconductors, embedded systems, design and manufacturing, all into under one umbrella. We need to first look at the size of India's consumption of electronics. So starting somewhere around $120, $130 billion today in 2021-22 financial year, which ends in a couple of weeks from now. By 25-26 financial year, India will be touching $320 billion worth of electronic products consumption in this country. So that's a big picture of what gets consumed in this country. And out of that, today, India probably manufactures about 30%. I'm sure Vinod will have the most latest data point, but somewhere in the range of 30 to 40%, give or take a couple of percent here and there, of electronic systems, which includes the cellular phones, the flat panel TVs, and everything, automotive electronics, and a little bit for aerospace and defense. All those major verticals include medical electronics, all those verticals included. And the semiconductor consumption out of the systems that are manufactured in India is currently in the range of about 15, best case $20 billion. And by 2025, when the consumption of electronics reaches $320 billion, the aspiration of India is to get at least 200 or $225 billion worth of electronics manufactured in this country. That is our aspiration, which also translates into somewhere between 75 to $90 billion worth of semiconductor consumption. What percentage of that we could manufacture in the country? There is an aspirational goal. What percentage of the total consumption we can manufacture? As I said, somewhere upwards of $200 billion. This is an aspirational goal this country has. And looking at how the Indian electronics manufacturing has shaped up over the last 2 or 3 years at best, the optimistic people in the industry like me, we believe that it is possible to reach those numbers. Because we have seen a phenomenal growth in electronics manufacturing in the country. In spite of many of the disabilities, the semiconductor shortage that the whole world is facing, and all the other infrastructures, I would say, are maturing, getting better and better day by day, but it is still has not reached the world-class levels that one would aspire for the next 3 to 4 years, for us to address all the key issues and still reach this aspirational goals of 200 plus billion or 225 billion kind of dollars worth of semi-electronic product manufacturing is the aspirational landscape that we have for this country. But the most important aspect which that's going to drive the whole of this happening is the government's unrestrained support. And the industry, I don't think, has seen anything like this before. They are fully committed. The policies are getting enabled in a very, very fast and furious, if I can use that phrase, way. I keep giving my favorite example when we were working with the government on the most recently announced semiconductor policy. India Electronics and Semiconductor Association was actively involved in that. And I used to get phone calls at 9 p.m. the night asking for some data points. And when I tell them that I will give you this by tomorrow morning, they said, no, please send it by 10 p.m. And the people who are the policy makers in the government are still in the office. And I haven't seen this kind of urgency and seriousness and impactful action from the bureaucrats anytime in my professional career. So the country is serious, the government is very serious, and the supporting parameters are all coming together to meet this aspirational goal. So this is the landscape as I can briefly put it in a couple of minutes that I will stop here. And I can come back and answer more questions later.
Great. Thank you, Mr. Krishnamurthy. Dr. Ravi, McDermott Alpha offers various solutions for almost all connected industries in this area, whether it's circuitry or assembly and semiconductors. In many ways, you are the barometer of, you know the exact consumption of various industries. Could you kind of enlighten us about where the future lies for, people who are trying to get into this industry, or even, to, like, you've spent a lot of time in the US with Alpha and previously Cookson. Now, with the India-US context, where do you feel electronics and semiconductors are going to be used even more than what it is being used today? And, on those lines, could you let us know your experience here setting up in India? And, also you're tied up very keenly with academic institutions. We'd like to hear from you.
Thank you, Shamil. Maybe I'll sort of start with what is going on in terms of, where is the demand actually going to come from or coming from? You really can look at two key things. One is the information flows, and the second one is the energy flows. I mean, the demand is coming for both of those things. The digitization and digitalization of India per se, and I'll talk about India initially. The and the growth of the consuming class. If the people having aspirational goals, etc. What's happening is that both information consumption and energy consumption is increasing, and the pattern of usage is also changing very significantly. So you can look at these factors in terms of information flows, such as starting from data centers, smart mobile devices, and sensor networks, and how that connects and plays together. And overlaying on top of that are the energy flows, that is energy generation, transmission, distribution, storage, and consumption and efficiency. These are all connected when you come right down to it. So in terms of, you asked me what is actually growing, you can actually overlay this in what Dr. Krishnamurthy said about really looking at what is the, where is the government Indian government focusing in terms of, for example, PLI schemes. And you'll see that a lot of these factors are reflected there. What I just mentioned, you will see solar module production, you will see electric vehicle production, you will see battery, ACC, PLI, you will see PLIs related to smart mobile devices, data centers, etc. So you will have all of these overlays going on. So you can actually pick apart um, these flows, really map the flows and look deeply at each layer and get at what is happening locally and where the opportunities are. That's probably the broadest answer I can give here. When you peel the layers back a little bit, in terms of the core technology platforms that underlie all of these, you're basically talking about RF, you're talking about electrical technologies, you're talking about electronic technologies, thermal, optical, protective technologies, and energy conversion technologies. So these are the technology platforms that actually need to be localized, if you want to call it that, in terms of its both technology and manufacturing capability. That means the technology and operations infrastructure and the value chains for these platforms need to be localized. And that comes really through having the right focus and strategy, getting the financial backing together to set up, having the technology and manufacturing knowledge, the people, and then building the ecosystem locally. And the ecosystem, I would say, splitting into two parts. I would put both the university ecosystem and the commercial and industrial ecosystem building. And you can split those into further what inputs are required for that. You need materials, components, equipment, people, and as inputs, and then the enabling activities, namely design, modeling and simulation, manufacturing and testing and reliability. I think that for anyone looking at opportunities, where are the opportunities? They can look at any of these dimensions that we just talked about, and there will be opportunity here. This is we are in a high growth cycle here right now. We are going to see significant growth over the next 10 years in India. And anyone who really wants to set up here can really look at their own expertise and financial and technological and manufacturing capability and localize that here, plug into what's happening in terms of the specific platform growth, and actually just make it happen. I think that we are in a fairly unique time in my view, and I can't overemphasize the need, I think, to build the ecosystem in concert. That means you have to build the university ecosystem, otherwise you won't get the people that you need to fuel the growth that you are going to see. And so it is super critical in my view to have both those ecosystem building efforts go hand in hand and simultaneously. So that's a quick answer. Hope that helped.
Certainly did, Ravi. And we have a few more questions, but we'll come back later.
Okay, sure.
Vinod, I called you a maverick because nobody was making, even today, we hardly think India is a component manufacturing base. We've got a lot of areas covered. We have a strong assembly base. We have a good embedded software base. We've got pretty much everything. What's really missing is the component manufacturing ecosystem. Now, you've been involved from the 80s. So there are challenges today, but I think the challenges might have been much bigger when you started off. And we'd love to hear from you about your whole experience, being involved in this in the component manufacturing when it was unheard of. And today it's a crying need for India to set this up. So how would you guide folks, how to set up in India?
Thank you very much, Shamil. Namaskar. Greetings to all our colleagues today on this panel. Thank you for having me. Yeah, you're touching upon something that I've spent almost 3 decades now doing. But before I get there, I want to share a little bit of the optimism and the excitement that both my co-panelists touched upon a little bit. And I wouldn't want to, of course, repeat anything they said. But if you look at it from the perspective of the market, which is always something which is very interesting, if you look at the per capita consumption of electronics in the world, we are looking at about $2.2 trillion over a population of about 7 billion. You're looking at about $300 per capita. In India, we're at around $60 per capita. So we have to catch up 5x as far as the average of the world is concerned. Next to that, I loved what Ravi said about how we are consuming more information and how differently we are consuming information. And the same goes with energy transition. My businesses and capacitors has a lot to do with energy, and we haven't had a more exciting time where you look at us moving from fossil fuels. I think the last time such a transition happened was 120 years ago, where we were still deciding between AC and DC. So today when you move, whether it's how we generate electricity, the whole renewables bit, the green energy bit, how we consume it, whether it's electric mobility, whether it's hydrogen, fuel cells, it's really up for grabs. And there is a completely new world order being set around these two concepts that Ravi mentioned. And that is another reason for us to be very excited with what's going on. A third and equally important reason is the whole geopolitical trigger of what's going on today. The need for us to de-risk, not put all our eggs in one basket, and not just, I don't have only our neighbor in mind, but the whole globalization did a lot of good. But in some areas, I think it created pockets of places where, for artificial reasons, we were manufacturing things at much cheaper than they should have been, and we got ourselves, if I may, be candid, into a trap in many ways, more than one. Now it's time to reset, and I think COVID has given us the perfect time to sit down in our homes and offices, rethink how we want to do this whole thing. And I don't think we could have had a more exciting. If there is only one regret that I have, which is that I think I was born 15 years too early or 20 years too early. So if I could reset that, I would be very happy. Now coming to components and what we've achieved, and as was rightly pointed out by you, we have reasons to feel very, very positive about what's happened, because let's remember that in my opinion, we made a big blunder in 1998 when we signed an agreement which my American colleagues will remember was called Information Technology Agreement 1. And the idea was that the developed world, led by US, was trying to tell us, the rest of us in the emerging and developing economies, hey, you guys need to lower your tariffs, make it an open field, and allow information technology equipment to flow wherever it needs to come. Because you know what? It will save your life. It will improve your livelihood. It will give you a lot of information. They were partly right. So we did that. Unfortunately, but the way this agreement got signed, it was not only information technology equipment, it was a capacitor, whether it went into power factor correction, whether it went into generation of windmills, or whether it went to automotive, it all came down to a zero duty as way back in 2005. So in a world which is not level, it will never be level, where our costs of energy, our costs of logistics, and our cost of finance was way higher than many of our neighbors, we were forced to compete in a zero duty environment. These factors of production are true for everybody. I mean, so there is no equal world. However, the impact of these disabilities is directly proportional to the amount of value you add. So if you were doing design in a nice designed house, these factors may not matter so much. It's the availability of talent, skills, IP that's very important. The ecosystem around intellectual property that will help you. And hence, in some of these areas where these factors didn't matter very much, India did reasonably well. We were punching in more than our weight at some point in time. When you came to assembly, there was a little element, we had an advantage in terms of labor arbitrage, if you may call it that, economic sites to assemble equipment. We lost out on things like logistics, and still finance was an important thing. So we did some amount of assembly. And what the government has done, very rightfully so, in the last 6-7 years, we've seen a change of policy. And now we've become, in some items like mobile phones, which is 40% of the $300 billion that Dr. Krishnamurthy mentioned, we have become the second largest assembly hub in the world today. So it's a moment to pause and congratulate ourselves for what we've done. But here is my concern. And I'm very happy that my friends in the government share that concern with me. What we've done is a horizontal deployment of a sector as an enabler, as a meta resource for a lot of other industries within, and that needed to be done. Marrying this with software and our firmware capabilities is fantastic. It augurs very well for the future. But hey, if we don't deepen this value chain, because don't forget that most value chains today are very integrated, and electronics for sure is very, very integrated. And I think the miracle that we see in China becoming a factory of the world is the fact that they have the most efficient integrated supply chain in the world that the world has ever seen. So from capital goods to raw material to components to assembly systems to the design, they managed to crack a lot of that. It's time that we have to build another such location. It doesn't have to be one location, but I definitely think India is a very competent candidate, given that we are a large marketplace, given that we have talents on design, on skilling, we have labor arbitrage, economies of scale can come in. And the most important thing, in my opinion, is that we have a need for customized solutions and products. An air conditioner that might work somewhere else in the world is not the best air conditioner, is not the most efficient air conditioner for India. Whether it's LED lights, whether it's EVs, I mean, even the definition of an electric two vehicle is very different in India than it is in China. A two-wheeler in India means you might carry a whole family, or some baggage on that two-wheeler too. So I think this, while on the one hand is a fantastic opportunity, is also a great challenge. Now, to the last part of what you asked me about components, what makes it even more difficult is that components typically are in an investment turnover ratio of 1:1 or 1:2. If I put $100 million in the ground, I will probably make $100 million worth of ceramic capacitors or film capacitors, somewhere in that area. It's also technology intensive. It moves quite quickly because in terms of miniaturization, in terms of trying to put more and more power, wattage, voltage through those capacitors or components. If you take the case of PCB, again, the multi-layer PCBs that we need today for our mobile phones. So it's fairly skill intensive. And then most importantly, it depends a lot on the raw material and the capital goods that go into making such an industry. And hence, anybody who wants to do this without an ecosystem could probably have done it wherever there was a large protection in terms of duties and these old age policies of wanting to spur manufacturing where it may not have naturally belonged. Those times are gone. So if you want to do this in zero duty, this is probably one of the largest policy challenges I can think of. In that environment, I think we've done reasonably well, but I keep reminding our colleagues in the ministry, the government, what got us to assembly will not get us to manufacturing. And which is why, as that impact of disabilities began to tell, erosion of value add began to happen. And in India, a lot of us who were deep down manufacturers in the 80s, if you remember black and white televisions, colored picture tube televisions, we had everything being made in India. The picture tubes were made here, the flyback transformers, the PCBs, the passives, the electromechanicals, the connectors. Not anymore. Today, if you look at a OLED display screen, or you look at a mobile phone or a laptop that I'm using right now, almost nothing. In fact, surprisingly, even the lead wire for my capacitors is today coming from either Taiwan, Korea, or China. So we have a lot of serious thinking to do in that area. But the good news is that I think once the assembly has started coming in, the design is beginning to happen in India. We are now talking of semiconductors and the heavy weightlifting that needs to be done there. It is natural that the need for passives, electromechanicals, PCBs, etc., to flow into India is absolutely it's being felt. It's being felt by very large companies like you. EMS players are feeling it. The designers are feeling it. But the glass is still half full, and our journey has just begun.
Fantastic, Vinod. So insightful and very crisp. I'll come back to you. There are many more questions. Now, about semiconductor manufacturing and the heavyweight lifting, I just want to share a personal experience. My first job was at Applied Materials before, of course, my Avalon responsibility. And as a beginner engineer, fresh engineer, my job was to go and stick labels on the various semiconductor tools which were rolling out from our assembly plants in Santa Clara. So I would see Taiwan, I would see, and this is the late 90s, so a good 25 years ago. And I would see so many, I would stick labels on various countries, and companies, foundries in those countries. Now a good 25 years have passed. If I was still starting my career at Applied, and if I got the same role, I still wouldn't get a chance to stick an India label on one of the tools shipping out. Now, all of you are really close to this area. You're, I'm sure, discussing, lobbying, and all of that to make this a reality and, change the trade fiscal deficit because of, importing all these high value components. Where are we today, and do we see a real reality setting in of a fab in India? I'd let each one of you answer. Mr. Krishnamurthy, maybe can you start?
Okay, sure. So if you carefully look at the entire ecosystem of semiconductors, way back in 1985, when Texas Instruments started their first design center, that's the time India started getting into very serious semiconductor design activity. But having said that, prior to that, there was still some amount of semiconductor design happening in discrete devices, power semiconductors, and even CMOS devices. In fact, when I was doing a calibration of India versus the rest of the world, and if you were to take a time frame like 1982 to 1987, the 5-year time frame, in India still were making semiconductor products like some CMOS chips in 5 micron and 3 micron technologies, which were not way behind where the world was. We were probably 1 or 2 steps behind the rest of the world at that time. But then the design part of the whole thing accelerated phenomenally from 1985 until now. It keeps accelerating from a pure play semiconductor design, whether it is system on chips, ASICs, analog products, mixed signal products, with the advent of almost who is who of the world setting up their offshore design centers in India. Very, very similar to the development of the software world. It all started with software testing way back in 1980. And the same thing happened with semiconductor. It started with verification. And then today, from this verification and layout, I think India has reached a fairly matured state as far as the design is concerned. There are very good capabilities in architecting a product, understanding the customer requirements, translating that into an architecture, and then realizing the architecture, taping it out, taking it to the fab, getting the fabricated part back, as test and characterize it, and get it ready for production. I think that part of the design ecosystem has been developed, and then the experts coming out of these captive design centers have also started setting up their own startups in large numbers. So I would say the first part of the puzzle is, I wouldn't say it is completely solved, but it is getting solved pretty fast. And we are seeing new startups in artificial intelligence, machine learning, medical electronics, coming up almost on a daily basis. So which is a very good part. Now you come to the second part of the piece, or second part of the puzzle, which is the wafer fabrication. Now, this is where, though India started with a fab in SCL Chandigarh, I think early 80s to, early 80s is when that went online. We haven't made significant investments, nor have we focused as a country in the to become a semiconductor manufacturer. And I think today the semiconductor complex in Chandigarh is still in somewhere in the range of 180 or 130 nanometers, somewhere in that range of technology node, and they haven't progressed beyond that. And it is primarily a strategic electronics manufacturing center, more of an R&D lab, I would call it, rather than a commercially focused volume production fab. So this is something which we do not have today. And then coming to the next phase, or the next piece of the puzzle, is the ATMP, the assembly, test, marking, and packaging. That is also not happening because the wafers are not happening in the country. So the recent semiconductor policy, where government has put in substantial financial muscle into the whole program, particularly for the silicon fab, going up to 50% of the cost, and the ATMPs anywhere from 30 to 40% cost. My expectation, based on all the data points that we have today, is that we will see a couple of ATMP units where the post-wafer assembly, test, packaging, and even the warehousing will happen out of the country anywhere from the next 12 to 18 months. And similarly, the compound fabs, both Ravi and Vinod talked about electric vehicles and energy-related products and its importance. The compound fabs, which are very critical for silicon germanium or gallium nitride for high voltage, high power devices, based on all the discussions that are happening and all the data points that we have gathered, I think the same is true for the compound fabs also. The next 12 to 18 months, we will see at least, this I'm talking about groundbreaking happening, not that they will be into production, but definitely groundbreaking will happen in this calendar year or early next calendar year. So this is what I believe is going to happen. Pure play silicon fab, I probably, it might take a little longer because that's heavy investments are involved, financial closures need to happen, and then return of investment need to be nailed down to a reasonable level of accuracy. Of course, the world is creating large amount of capacity for fab, because if the today's revenue for silicon semiconductor is somewhere in the range of $450 billion, and by 2025 it's going to go to $600 billion as projected and predicted by many pundits. Then we are talking about approximately a 33% growth, or it translates into approximately 15% or 14% CAGR. That requires significant amount of assembly capability, test capability, packaging capability, and the entire distribution network. So I am sure India is going to get into that, that's for sure going to happen. And so also the compound fab, because by end of this decade, all the predictions and all the data points that we have gathered points to the fact that maybe 40% to 50% of all the vehicles that are on the road will be electric driven, or at least hybrid, if not fully electric. So that's a huge transformation that's going to happen. And as Ravi said, we need to connect, peel the onions and connect all the underlying layers. And I think this is definitely going to happen. And so this decade, and I've been talking about it in various forums, is probably going to be the defining decade for India when it comes to electronics. And the pure play silicon fab, of course, today I saw that IBM announced a 2 nanometer chip sheet, at least in the R&D, in their R&D, which is way ahead of where others are. So the silicon fab, challenges will take a little longer before India solves it, but it will eventually happen, because even today, if you look at the pie and slice the pies, I think the FinFET nodes, which are below 16 nanometer, are still consuming only 22% of the total silicon that's produced in the world. Others are all in the planar nodes, 22 or 28 nanometer and above that. So there is enough room for India to get those nodes and try to get into volume products, which can still be consumed significantly within the country and also becomes an export. And if you replicate the story that we are doing today in the cell phone manufacturing, though I think Vinod was spot on when he said how much of value gets added is finally what matters. I think we will start becoming initially probably a second source for manufacturing semiconductor products of pure play silicon fabs, and then that is 22 nanometer and above for a few years before we catch up with the rest of the world. But that's perfectly okay, because we don't have to make those tens of billions of dollars for that 20-25% of the market share. So this is the way I would expect, and many of us in the India Electronics and Semiconductor Association, we read the landscape to play out this way. Thank you.
Wonderful. Thank you, Mr. Krishnamurthy. Dr. Ravi, as you know, we are involved in electronic manufacturing services. We serve OEMs across verticals and supplying to various parts of the world. No matter which customer, every one of them were challenged with semiconductor shortages. And what we are made to understand is, the raw materials which go into the wafer fab process is where a lot of the challenge is. And you're pretty close to that industry. So from whatever you know, can you let us know, have we seen the bottom, the worst is behind us, or when do you feel things might just get back to normal?
It's a really good question. I think, if you were to ask me before the Russia-Ukraine war broke out, I would have probably said sometime late second half of this year, things would ease up. There's a lot of, as Krishnamurthy said, there's a lot of capacity that is being, that will come online. I think there's balancing that is going on, etc. Remember the backdrop. The backdrop is that everything is being, quote unquote, electronified, right? Everything. And you take something as ubiquitous as an automobile, the electronic content is just growing astronomically, and so the demands are dramatically increasing. This whole thing probably started because when COVID happened, so to speak. I don't think the semiconductor industry really figured that the automotive industry would bounce back as quickly as it did. And so maybe some of it was that they had shifted capacity away from automobiles into other sectors, etc. But clearly, the demand resurgence probably caught everybody by surprise, so to speak. But clearly, when you factor in geopolitical disruptions like the one we are seeing right now, then you do see that if something is being manufactured in either of those two countries, you will start seeing shortages of those things, those raw materials, and that does obviously have an impact. Global companies have tried to insulate themselves from these shocks by building inventory and making sure that at least they can weather the storm for a period of time. But it's a very clearly a tough situation, so to speak, because what you're looking at is a very, very complex supply chain and very complex products, and you need, it's like assembling a car. You need every last bolt to assemble the car. You kind of sell the car without the last bolt, and it's essentially the same with something like a semiconductor. You really need everything to make it, and therefore your supply chain globally has to function in a very smooth manner. So all the disruptions we've seen in logistics and transportation, etc., all of those things have impact. So what does this really get us to, right? Where does this bring us? The reality of the situation is that everybody is now coming to the conclusion that you have to de-risk. You can't assume that you can depend on one or two geographies, countries, for example, to deliver. You have to have multiple areas where you can tap into and build a resilient supply chain as an industry. I don't think that the days where you had a really well-functioning, stable global environment, not going to be there going forward. You'll only see more volatility. So that de-risking is what Vinod was talking about earlier. The de-risking is going to have to happen, going forward, and we will have to find or sort of, should I say, hedge across multiple geographies in order to source the materials. So remarkably, I would say that everything is moving. In spite of everything that you hear, it's not like things are coming to a grinding halt. We thought, COVID, broke out, everything's going to go belly up and we are going to have a serious issue. And lo and behold, everything moved, right? And we found ways of getting around these things. And so I believe that, it's a matter of the industry getting together and figuring out what the alternatives are and then just implementing them.
Thanks, Dr. Ravi. I guess there's no easy answer to that question, but let's hope situation gets better for maybe what you're saying. Apple, they were able to produce their phones, but I'm thinking about a company which makes ventilators. Their demand is really small. So are they getting the parts they want? So there is serious allocations happening in this business, and we just hope that things get better. You're very close to, or you're on several panels, several industry bodies, advisory roles for various activities. Now, there are a lot of schemes the government has come out with, right, that to bridge this, the semiconductor or the component base. So how is it all playing out, whether it's the specs or the PLI or the EMC? Is it today, an impression is that it's meant for the big companies or the global companies to set up. But how does it play out for smaller entities in India?
My opinion, in the last 3 years, the world has changed, and it has changed irreversibly. And whether we like it or not, so one good thing that happened in 3 years is that even governments like the government of India had to take a call and say, hey, there is no more going on this business of electronics without semiconductors. And such a moment came about 7-8 years ago. I remember in the previous government, and it's an anecdote that sort of says how the thinking in the government is changing. So I remember having gone with 2 of my colleagues from the industry to the then finance secretary. And we were doing our usual round of telling him what support we needed from the government and why without the government support it was going to be very difficult. He said, let me cut it short and make it very crisp. Please answer, gentlemen, are you guys globally competitive or not? And so one of my colleagues fell into that trap literally and said, yeah, no, we are not globally competitive. And so he says that, you see, if you're not competitive, we don't have to be competitive in everything. So please go and read this book about competitiveness of nations, etc. Say through some of those books and says we don't have to do everything. And if you guys are not good at this or not competitive at this, my suggestion is go do something else. I was personally very taken aback, and I didn't take it too well. And so I told him, "You are so right, Mr. Secretary. I always had a desire to open a nice bar, maybe a dance bar with some Bollywood music. And so thank you for guiding me in the right direction. because I thought my job was to put some capital to work and create some jobs for this country. Now that you point me in the right direction, so don't worry about me because I'll take care of myself. But I wonder if the whole country can afford to let go of a bus called electronic hardware manufacturing. So we are a 1.3 billion people, right? There are some things you just cannot depend on. I mean, oil, it just so happens that we don't have it, so we have to import it. But I don't see ourselves brushing away facts like this and saying these are sectors, because I reminded him that this is not a sector, it's not a vertical, it's not an industry, it's a meta resource. You cannot say, oh, we can't make electricity in this country, we can't generate it, so let's do without it and let somebody else do it for us. Now, fortunately, a similar moment has come today for semiconductors, in my opinion, to begin with. We are seeing what might be, not out and out, but there is weaponization of not just semiconductors, but weaponization of supply chains happening today. Countries will deny each other, as we see also in the current Russia-Ukraine war. The sanctions are all to do with denial of technologies, denial of components, and denial of supply chains or designs, or in some form or the other. So I think it's very important that at least some of us take a very serious call at this. Some countries did. India was not one of them. And you asked me a question about what is my feeling about how do we work with the government. The truth is that for too many years in this country, the government and industry, or the government looked at the industry with a large amount of mistrust. And I say this because it's not the first time we're discussing semiconductors. 10 years ago, Dr. Krishnamurthy will bear with me, there was a policy called SIPs. In fact, the MSIPs came much later, the Modified Special Incentive for Package for Semiconductors. It was first called a Special Incentive Package for Semiconductors, SIPs. I think there were more than 12 or dozen applicants. Nobody qualified, and nobody saw the those files being put. And when I asked the secretary, I can share this with you, he just said, look, I mean, in this government, in those days, I'm talking about 10 years ago, 8 years ago, he said, you'd be foolish to sign on a file that signs a check of a few thousand crores to one company. How do we know it's not gold plated? And nobody wanted to take these tough decisions. So I'm very happy today. For the first time, I'm beginning to see, and this is a term I borrow from my colleagues in the government, where they say the whole of the government is beginning to work together. I think Ravi very rightly, very articulately pointed out, look, this is not just somebody bringing one fab, whether it's a 22 nanometer fab or 180 or one of these pure play silicon fabs, whenever that comes, you've got to construct a whole ecosystem around this. Whether it's the infrastructure that the state has to provide in terms of unencumbered land with no issues around it, clean water supplies, clean energy, uninterrupted energy. These are not things that are that you can take for granted in a country like India. The relationship between the state governments and the center governments, we saw a UP government with a double engine sarkar. So if you're going to do something like that, you better be careful where you're putting that. So those are still thoughts in play when you're putting in large investments like this. But when you say EMC, the EMC 1.0, for example, Alcina actually put up their own. This is one of the first private sector-led clusters where 25 companies came together and said, hey, let's go and do this experiment in Pakistan, and debated that. It wasn't an extremely pleasant experience, I can share with you candidly. Why? Because while the central government thinks it's important to bring electronics to India, some states don't think that way. And within the states, the industrial
we might have just lost Vinod there, I think. We are kind of...
I think I dropped off.
Okay.
Sorry, I'll just complete that point and then I'll be back to you. Yeah. So I was saying, now fortunately, the EMC 2.0 version is something where the state governments have to lead it. So we are learning from our mistakes, to answer your question. The SIPs gave way to MSIPs, which later gave way to now what we call specs, which is definitely a much better version of what we saw there. So I'm very happy to report that the government and the industry is learning from some of the mistakes we made earlier.
It's great to hear that. And it's quite clear that, deepening our value chains from assembly to manufacturing will require more of what we have witnessed in the last few years, the government's high focus on developing the industry, bringing in the best policies in place, and more than anything, courage to take some tough decisions and, have a strong belief in our industry. I want to thank each and every one of you for very insightful comments. Look forward to a better India with a lot more electronics and semiconductor action in the days to come. Thank you all.
Thank you.
Thank you.
Thank you.
Thank you,
Thank
Shamil.
you.
Thanks, lovely.
Yes. Just for everybody's information, in a little while, we have a nice presentation from an IPC Vice President, Mr. David Bergman, on the factory of the future. It starts at 1:30 p.m. EST if you're watching from the US, and in India it's at 11 p.m. IST, which is, I guess, an hour and a half from now. If you're up to it, I think it'll be well worth the watch. So thank you all.
Thank you.
Thanks again, Shamil.
Thank you, Shamil.
Thank you all.
Bye-bye.